Hello everyone. Today, it is my great honor to share the research findings of Professor Chao Yongchang's team from Sun Yat-sen University, which focuses on Akkermansia muciniphila enhances chicken resistance to infectious bronchitis virus by boosting GABA synthesis and suppressing the NF-κB inflammatory pathway. Background: infectious bronchitis virus IBV causes respiratory diseases with high mortality in young chickens, leading to millions of US dollars in annual economic losses. Existing vaccines show poor cross-protection against new IBV variants. Therefore, new prevention and control strategies are urgently required. Highlights: by integrating multi-omics technologies, we systematically characterized the intestinal microecological features of adult chickens and chicks for the first time. Based on this and combined with a newly established persistent IBV infection model, Akkermansia muciniphila was identified as the key bacterium enhancing young chickens' resistance to IBV. It enhances host resistance to IBV by increasing GABA levels, which inhibits NF-κB-mediated excessive inflammation and promotes antiviral interferon responses. Adult chickens show significantly higher resistance to IBV than young chickens. Epidemiological surveys and challenge tests indicated that IBV induces higher mortality in young chickens than in adult chickens. Using a fecal microbiota transplantation model, it was demonstrated that transplanting adult chickens, but not young chickens, intestinal microbiota significantly improved the survival rate of recipient young chickens post-IBV infection. Intestinal microbiota structure differs significantly between adult and young chickens. To clarify the mechanism by which intestinal microbiota affects chicken resistance to IBV, integrated microbiomics, viromics and untargeted metabolomics were used for systematic analysis of the intestinal microbiota. Results showed that the microbiota structure of adult chickens was similar to that of young FMT chickens, but significantly different from that of young chickens, with higher microbial diversity. Intestinal virome structure differs significantly between adult and young chickens. Metatranscriptomics results showed that the viromes of adult chickens and young FMT chickens were more abundant than that of young chickens, with minor differences between adult chickens and young FMT chickens. Untargeted metabolomics results showed that the intestinal metabolic profiles of adult chickens and young FMT chickens were more similar, and both were significantly different from that of young chicken. Differential analysis indicated 2,239 differentially expressed metabolites in adult chickens compared with young chickens. Akkermansia muciniphila is a key biomarker for young chickens' survival post-IBV infection. Using a persistent IBV infection model, it was found that microbial richness decreased on days 3 and 5 post-infection, and partially recovered on day 7. Among them, Akkermansia muciniphila increased significantly post-infection with the highest fold change, rising by 6.3 and 6.6 times on days 5 and 7, respectively. Oral administration of Akkermansia muciniphila upregulates GABA and improves young chickens' survival rate. Functional tests results showed that oral administration of Akkermansia muciniphila significantly improved the survival rate of young chickens post-IBV challenge, which resulted in a highest upregulation of GABA. Akkermansia muciniphila enhances young chickens' resistance to IBV via GABA-mediated NF-κB. Following results showed that administration of GABA significantly improved young chickens' survival rate. Detection of P2Y protein expression in chicken kidneys revealed that GABA treatment significantly inhibited IBV-induced P2Y phosphorylation and nuclear translocation, thereby alleviating NF-κB-mediated inflammatory responses and renal tissue damage. Summary: systematic multi-omics analysis comprehensively elucidated the intestinal microenvironment of chickens of different ages and revealed its dynamic changes. Akkermansia and metabolite GABA associated with IBV resistance were identified, and the mechanism by which Akkermansia improves young chicken survival rate by inhibiting NF-κB-mediated inflammatory responses was clarified. This lays a theoretical foundation for the application of live biotherapeutics in the poultry industry, further expands the application scenarios of Akkermansia and GABA, and provides a new paradigm for microbiota-driven antiviral strategy research.